So there are two main types of there are two different types of training modes, and they require different types of training data. Let's put a different example. I have here a Mac, and if we were to do what's called supervised learning, we would need label data. That means that we need the bounding box that we've been talking all along, and that we need a lot of images of Macs with different angles, different things, and we would then train the model, and we would have a detector for Macs. That's a labeled data set, supervised learning. That's the main one. And that's the most common one, and now it's very cheap because there's quite a lot of pre-trained models that we can leverage, so we don't need to train everything from scratch. The other mode would be to use what's called unsupervised learning, which is images of Macs, but now without the bounding box. So what do we do if we don't actually have the output? What we can do is we can use certain types of techniques. Like there's two main ones. The first one would be to try to generate the intermediate features for certain types of images. Like there's a lot of data sets with real world images. So anything that you can take with a regular camera, that's pretty much covered. But imagine that you're trying to do something more specific, something that there's not so much data about, like pictures of cells or something like that. Like the feature that you're going to get from an eye and what you're going to get from an actual cell, it has nothing to do with it. Like there is these intermediate features, they don't translate well into the other application. That's when you can start to use unsupervised learning in order to leverage this data, even if it's not labeled. But at some point you will need a little bit of labeled data. I'm just saying, like, if you have a massive amount of unlabeled, you can use it to make the training easier down the lane. These are the two main types of training data, but the important features is like the quality of the data. What does it mean that the quality of the data? By quality, we refer at different situations. So imagine that you have a very controlled environment, something that is in a factory or something like that. You know that the illumination is going to be very constant. You know that certain positions or reflections are not going to be there because it's like something a lot more stationary. It's not going to change that much. Maybe there's going to be a little bit of a shadow of some operator or something like that. But there's not going to be one day that there's like a lot of sun, the other one that's overcast. The conditions, they're not going to change that much. So in that particular case, you don't want a lot of variation. But if you are trying to do a cat detector, what you would need is a lot of images in cats in very distinct positions, like not only like walking with the feet behind their neck or anything like that. It could also be like different illumination, different poses, different fur colors, different types of cats, breeds, whatever it's called. I'm not a cat person. And then also the quantity of the data. So like if you have enough variability, then the model can start figuring out what is a cat, even if you don't have a lot of data. But if you have a massive amount of data, then this can be actually paid a bit less attention, because like just by having a massive amount of data, you already start to have a bit more variability naturally. So those are the main things. For small projects, which are probably the ones that need to pay most attention to the data, I would say like focus on quality. That means high resolution images, very good bounding boxes. What it means, like this, it's too loose. It needs to be as tight as possible to the object that you are trying to detect. And also make sure that the situations encompass all the different situations that you want to represent, illumination, positions, and stuff like that.